Hello, welcome to Learning-Riti. My name is Dr. Hemant, and today we are going to see the fifth lecture of the chapter 1, which is physical world. And in today's lecture we will see nature of physical laws. In other words, you can say nature of nature. So till now we have seen that how in physics we try to explore the phenomena in nature, we try to decode nature, and now we are going to see in this lecture that what is the nature of nature, like how these physical laws behave, what is the nature of these physical laws. Okay. So as a physicist, we explore the universe based on scientific process from microscopic level to macroscopic level, meaning from atomic and molecular scale to large size objects which is far away from ours. Also in physics we explore the facts based on observation and experiments, and along with that, as a physicist we also try to find laws which are summarizing all these facts. And further, in any physical phenomena governed by different forces, several quantity may change over the time. For example, kinetic energy may change, potential energy may change, total angular momentum, energy. So all there are different physical quantities involved in the different processes, and they may change with time. But very importantly, there are some physical quantities which however remain constant in time. They are conserved. We call them conserved quantities. Because if you talk about all these conserved quantities, then energy is the central. In physics we always talk about energy. The concept of energy is very much important, and it can be expressed in for every physical system, and we are talking about model, and then most of the time we will see that when we are trying to solve the questions and equations in physics, we move with those equations basically based on some conserved quantity. For example, mostly in the case of energy or total angular momentum or linear momentum, kind of that. And those kind of conservation laws are very helpful in solving many complicated and tedious processes or phenomena observed in nature. So and a very important fact about the conservation of energy is that it is true for all forces and any kind of transformation between different form of energy. For example, you consider the free fall of an object. So for example, this is going and this is your ground and it is falling. So as you know, the potential energy which will be based on its height, and the kinetic energy which will be based on the velocity, and total, if you talk about kinetic energy and that potential energy, so the sum will always remain constant, and that is, you can say, the total mechanical energy. But with time you see the kinetic energy changing as it is approaching towards the ground, and the potential energy is changing because the height is changing. So you can see that how that independent quantities like kinetic energy and potential energy is changing, but the total sum is not going to change. So this is the total energy remains conserved in this, and this is a very important concept when we are trying to solve these kind of problems where that objects are falling from there, and then we are trying to find that what would be the situation, what would be the energy at given point of time, or any other physical process phenomena at intermediate time, and based on that we can have a very precise mathematical models and equations which is based on the total energy constant process, and that can be used to solve these kind of complicated problems. So you can see that how central it is for the study of physics, conservation law in the study and exploration of the physical laws or physics nature. And again, to mention here that as we have discussed in the last lecture, that conservation law is a hypothesis. It cannot be proved. It can be verified with observation and experiments, but it cannot be proved. So that's why we call it conservation law as a hypothesis. And the conservation of energy is considered to be valid for across all domains of nature from microscopic and macroscopic level. So when we say hypothesis, it means that it cannot be proved. Means that I have repeated many times in my previous lecture also, and this also, it is considered to be self-evident truth. And if we assume that this is true, then we can explain many process of phenomena in nature. So now you can say that, okay, then what is the experiment for? Why the observation experiment? So to clarify here is that when you do experiment or observation, then you just verify a given phenomena or hypothesis, but you don't prove it. On the other hand, if a single experiment disapproves your hypothesis, then that hypothesis is not valid. You have to discard it. You have to look for the other one. So you should not ask someone to prove the conservation law of energy. You just can ask to verify it, not to prove it. And many times we can find that the conservation law may be considered to be true at certain point of time for a given quantity, but it may change or it may not be valid. For example, the Einstein theory of relativity, before that mass conservation of mass was considered to be a conserved quantity in all frame of references, but now after theory of relativity it is found that mass is not conserved. But still, this is conservation is not for all frame of references, but for in given frame of reference in a given condition, it is still valid. You can assume it conserved. For example, in chemical processes, if we talk about, you are talking about the chemical process is nothing but the arrangement of the atoms in different molecules, the rearrangement again. So in this process, you may find that the loss of mass, because the binding energy between the atoms changes from one type of chemical to the other type of chemical. If the total binding energy in the previous, before the chemical process and after the chemical process, the difference is positive, means the binding energy is less after the chemical process, then this heat will be, or the some energy will be released. And if this is the vice versa, for example, the latter is having higher binding energy, means then you have to supply energy to it, and then that will consume energy. So similarly, it will be defined for exothermic or endothermic chemical reactions. But in this case, you would see that since the total, this is merely the rearrangement of the atoms or molecules inside a chemical reaction, so, and this is not going to change the mass in a very significant way which can be noticed. So you can say that the changes in binding energy are too small when these chemical reactions are happening, that we cannot detect these changes in mass. They are very small, because if even a minute amount of mass conversion to energy will be huge, and in chemical reaction the extent you take out in terms of heat or energy is really not that much which you can measure as a loss in mass. So after the reaction and before the reaction, you will find that the total mass is almost the same. So in this case you can consider that mass is a conserved quantity, but if you talk about different frame of reference moving near to the speed of light light, then you will see that mass is not a conserved quantity. It will be varying depending upon the speed of the in which frame of reference you are talking about. But again, this is all advanced topics, but just to give you a glimpse that how conserved quantity plays a role in solving complicated and tedious processes in physics. But in certain times it may not be conserved in many frame of reference, for example mass, but it can be in a given situation. In current scenario, for example, we are talking about different domains, and then in one physics domain it can be considered a conserved quantity, but in a larger scale, if you go in a different domain where we are going to increase the its validity scope, then there we may have to accordingly adjust or modify or take the account all the additional conditions into it, and then you have to assume what is that. So meaning to that that you have to be very careful when you are applying the physics laws, and where you are applying, what are the conditions and the terms and conditions and the applicability, you have to know very well. And once you become a very good physicist, you will have a very good understanding of it, that what applies, what not applies. And many times in your when you study, you solve the problems, you will find it that okay, understanding of these limits is very important, that which laws I should use, which one I should not use. So those understanding will come only from experience as you proceed in this area. So moving further, so laws of nature remains everywhere same in the universe. However, the phenomena may be differ from place to place. because of different condition at different location. So meaning to say here is that the nature laws of nature remains the same. For example, if you measure the gravity on an object in a laboratory today, and after 1 year under similar condition with the similar objects, you will find the same value. The gravity remains the same, but it may be different in different conditions. Concept that gravity is attractive, it is working on the two different masses, that is true in here on Earth as well as on Moon. So but only change quantitatively because the conditions are different and the location is different. The laws of nature do not change with time. For example, there are some general conservation laws in nature include laws of conservation of mass, energy. Of course, as I said, that if we talk about relativity, and then we have to be conscious that how that conserved quantity parameters can be redefined adding with the certain conditions, but at certain domains it may explain most of the activity in a given defined conditions. Further, angular momentum, charge, parity. Some conservation laws are true for one fundamental force but may not be other. So you have to be understanding, and to understand this you have to understand the physics better, and whenever you learn about the laws and the theory, then you always focus on that the validity range, in what condition it is valid and when it is not valid. If you have this understanding, you will become a very good physicist. So with this I think we have completed our first chapter, where we have seen what is physics and scope and excitement of physics, its connection with the technology and society and different forces in nature, and how the unification, we are moving towards the unification of forces. Also you have seen that what is the nature of nature, the nature of physical laws, and in next section we will discuss the summary of this chapter and also some question answer, and we will see that what should be our approach in solving complicated or normal physics problems, what should be our focus, and what to look for, what not to look for. So with this, let me end with this chapter and see you in our summary chapter. Thank you.